Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 6, Algebra of Points and One-Dimensional Coordinate Systems. Section 59, Projective Correspondence between the points of two different lines. Exercises. 1. Give constructions for subtraction and division in the algebra of points on a line. 2. Give constructions for the sum and the product of two lines of a pencil of lines in which a scale has been established. 3. Develop the point algebra on a line by using the properties expressed in Theorems 2 and 4 as the definitions of addition and multiplication respectively. Is it necessary to use assumption P from the beginning? 4. Using corollary 3 of Theorem 9, Chapter 3, show that addition and multiplication may be defined as follows. As before, choose 3 points, P0, P1, P infinity, on a line L as fundamental points, and let any line through P infinity be labeled L infinity. Then the sum of the 2 points, Px and Py, is the point Px plus y, into which Py is transformed by the elation with axis L infinity and center P infinity, which transforms P0 into Px, and the product Px times Py is the point Pxy, into which Py is transformed by the homology with axis L infinity and center P0, which transforms P1 into Px. Develop the point algebra on this basis without using assumption P, except in the proof of the commutativity of multiplication. 5. If the relation ax equal by holds between 4 points a, b, x, y of a line, show that we have the quadrangular set Q of 0, b, a, comma, infinity, y, x. Is assumption P necessary for this result? 6. Prove by direct computation that the expression, the quantity x1 minus x3 divided by the quantity x1 minus x4 divided by the quantity x2 minus x3 divided by the quantity x2 minus x4 is unchanged in value when the 4 points x1, x2, x3, x4 are subjected to any linear fractional transformation x prime equal to the quantity ax plus b divided by the quantity cx plus d. 7. Prove the transformations lambda prime equal to lambda prime equal to 1 divided by lambda prime equal to 1 minus lambda prime equal to 1 minus the quantity 1 minus lambda prime equal to lambda divided by the quantity lambda minus 1, lambda prime equal to the quantity lambda minus 1 divided by lambda. Form a group. What are the periods of the various transformations of this group? Chiefly Theorem 13, Corollary 3. 8. If A, B, C, P1, P2, Pn are any n plus 3 points of a line, show that every cross ratio of any 4 of these points can be expressed rationally in terms of the n cross ratios lambda sub I equal to the cross ratio R of AB, C, Pi, where I equal to 1, 2, n. When n equal 1, this reduces to Theorem 13, Corollary 3. Discuss in detail the case n equal 2. 9. If the cross ratio x1, x2, x3, x4 is equal to lambda, show that 1 minus lambda divided by the quantity x3 minus x4 is equal to 1 divided by the quantity x3 minus x2 minus lambda divided by the quantity x3 minus x1. The relation of corollary 3 of Theorem 13 is a special case of this relation. 10. Show that if the cross ratio R of AB, CD is equal to R of AB, DC, the points form a harmonic set H of AB, CD. 11. If the cross ratio R of AB, CD is equal to lambda satisfies the equation lambda squared minus lambda plus 1 equal to 0, then the cross ratio R of AB, CD is equal to R of AC, DB is equal to R of AD, BC is equal to lambda. And R of AB, DC is equal to R of AC, BD is equal to R of AD, CB is equal to minus lambda squared. 12. If A, B, X, Y, Z are any 5 distinct points on a line, show that the cross ratio R of AB, XY times R of AB, YZ times R of AB, ZX is equal to 1. 13. State the corollaries of Theorem 11 in homogeneous coordinates. 14. By direct computation, show that the two methods of determining the double points of a projectivity described in sections 54 and 58 are equivalent. 15. If the quadrangular set ABC, XYZ, then the cross ratio R of AX, YC plus R of BY, ZA plus R of CZ, XB is equal to 1. 16. If M1, M2, M3 are any 3 points in the plane of a line L, but not on L, the cross ratios of the lines L, PM1, PM2, PM3 are different for any 2 points P on L. 17. If A, B are any 2 fixed points on a line L, and X, Y are 2 variable points such that the cross ratio R of AB, XY is constant, the set of points on X is projective with the set of points on Y.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.